Let's prove the section formula for internal division. We take the coordinate axis and draw the line AB on it. The coordinates of A and B are x1, y1 and x2, y2. And we have a point P between them with coordinates x, y. There is another piece of information we have been given. The ratio of AP to PB is the same as the ratio of M to N. So this is all we have, and we need to find the coordinates of point P in terms of x1, y1, x2, y2, M and N. There is a small bit of construction we need to do here. So let's zoom out and continue the proof on the right-hand side. The first thing we need to do is draw perpendiculars from points A, P and B on the x-axis. Let the perpendicular from point A onto x-axis meet the x-axis at point C. Since AC is perpendicular to the x-axis, its x-coordinate will be the same as that of point A's, which is x1. As C lies on the x-axis, its y-coordinate will be 0. Similarly, a perpendicular from point P onto the x-axis will result in point D with coordinates x, 0. And the perpendicular from point B onto the x-axis will result in point E, x2, 0. Why are we doing all this? How are we heading towards finding the coordinates of point P? We can see that we have three lines which are parallel to each other. Segment AC is parallel to segment PD, which is parallel to segment BE. And there are two transversals intersecting them. One transversal is AB and the other is the x-axis. So here the concept we will be using is ratio of intercepts formed. CD and DE are the intercepts formed by the x-axis, and AP and PB are the intercepts formed by AB. As we have three parallel lines here, we can say that CD by DE is equal to AP by PB. We know that AP to PB is M by N. The next thing we need to do is find the length of CD and DE. Finding these lengths is simple as we have both the points on the x-axis. Length CD will be x minus x1. Length of DE will be x2 minus x. Now it's just a matter of simple calculations. X minus x1 divided by x2 minus x will equal M by N. As we are running out of space, let's erase this and write it down again. X minus x1 divided by x2 minus x will equal M by N. Cross multiplying, we get N multiplied by x minus x1 will equal M multiplied by x2 minus x. Now all we need to do is get the variable x on the left hand side to get the x coordinate of point P. Using the distributive property, we get nx minus nx1 equal to mx2 minus mx. Getting the term with variable x in it on the left hand side, we get mx plus nx equal to mx2 plus nx1. This term was transposed here and this one was transposed here. As x is the common factor on the left hand side, we can write x multiplied by m plus n will equal mx2 plus nx1. Now we just have to transpose m plus n to the other side. Finally, we get the value of x as mx2 plus nx1 divided by m plus n. Well, that's your proof. It's long, but definitely easy. All we did was draw perpendiculars from the 3 points and use the concepts of ratios of intercepts. Similarly, if we draw perpendiculars from the 3 points to the y-axis, we get the y-coordinate as my2 plus ny1 divided by m plus n. The formula tells us that given the ratio of the lengths and the coordinates of the endpoints, we can find the coordinates of the point in between the endpoints.